So with quadratic equations, or word problems, we're usually talking about throwing something, dropping something, so on and so forth. Now, most of the time, just like in that example number 65 on the 2013 final, they gave you the formula. The trick is you got to figure out what all the numbers they gave you, where it goes in the formula, plus you need to also make sure that you have only one variable left in order to solve it. So we're going to work on that 583, 584, and we're going to do 38, we're going to do 40, and we're going to do 60. The rest of them are going to be on your shoulders. And then you have the next 10 questions off of the 2014 final. So on page 583, we're dealing with word problems using quadratic equations. So let's look at number 38. Now in the directions for 38, actually let me lower that. In the directions for 38, it says for exercises 38 to 41, use the formula negative 5t squared plus v sub 0 t plus c equals h. Now, we had talked about when we did this problem before that they actually had some examples of this in the lesson, and it actually kind of described what each of the variables meant. Now, one of them is super simple, right? What's t stand for? Time. So that's easy. Your t is your time. What did v sub 0 equal? Initial velocity. And in this case, this would be initial upward velocity. And I can tell it's initial upward velocity because the negative 5. Now, if you remember, problem 65 also started with a negative, and they described what that negative meant. Why do we have a negative 5 in front of the t squared term? What does that represent? Ian? Nope. Nope. No, it hasn't. Well, that's, I mean, think about it. You throw it, you're always going to get a downward facing parabola. But they actually gave what that number represented in this actual situation. You're doing this, you're tossing something, and does the ball just go forever up in the sky? No, what eventually happens? Why? Gravity. So that negative 5 is telling you that's the pull of gravity in this particular situation, okay? That number changes depending upon the situation, but the reason why it's negative because that's the pull of gravity bringing it back down to the earth, okay? And then they talked about, let's see, C. What was C?
The starting height.
Yeah. It's your, we'll use the word initial, kind of keep it the same. That's the initial height, where your object was when you then exerted the initial upward velocity on it. And then, what's the h value? Miles? Yeah, it's the height at some time. So it's the height at a specific time. And for most of the purposes, the time that they're looking for is the height or the time when it's hitting the ground. So when you hear that word ground, that's telling you your height is now at 0. In other words, ground 0. Bam, you're back to where you started. Okay, or actually lower in most cases, because if you're starting upright and throwing something, it still has to come all the way to ground. So anytime you hear that idea of ground, that's telling you that the height at that specific time is going to be 0. Okay? So let's look at number 38. A ball is thrown upwards from a height of 20 meters with an initial velocity of 15 meters per second. In about how many seconds will it hit the ground? Okay? So based on those numbers, let me get this guy, move him down. What does the 20 meters represent? C. That's where it started initially, bless you. What does the 15 represent? The initial velocity. Because if you look at the label, it says meters per second. So that's 2 of the 4 variables. We need to get one more variable to put a number in its place, otherwise we can't solve it. So what's the last thing it says to us?
Ground.
It hits the ground. So what does that allow us to write for which variable? So the h equals 0. So now we're ready to solve this problem. So the only variable we don't have is t, which is great because that's what they're telling us to solve for. At what time? So I have negative 5t squared plus 15t plus 20 equals 0. All right, so now, how do I begin this? What do I do? Lucas. They're already there.
And constants.
Nope.
Oh, wait, no.
You get everything on the left, 0 on the right. So we're good at that point. Brian?
You can factor out a negative 5.
Yeah. Not only do we want to factor out the 5, but he's absolutely right. We got to pull out that negative because our best attempt at this is going to be factoring through normal means, right? So let's pull out a negative 5, and that gives me a positive t squared minus a 3t minus a 4. So now, if we play the game, what are factors of negative 4 that add to give me negative 3? Negative 4 and positive 1. So because my quadratic coefficient in the parentheses is equal to 1, these two values in the game actually become the values in the binomials. So I still have the negative 5, and then I have a t minus 4, and I have a t plus 1. All of that equals 0. Now this is one thing I noticed in past is that you guys like to drop off the equals 0 and you stop it being an equation, and then you can't solve it anymore. So you have to keep the logic constant through the whole problem. Now, negative 5 can't equal 0, so I don't even waste my time with that one. I only spend my time setting any kind of term that has a variable equal to 0. Because, again, I'm solving for t in this problem. At what time will it hit the ground? So we do opposite operations. So I get t equals 4. Subtract 1. I get t equals negative 1. Okay, then I look at my answers for reasonableness. Is there any answer that's not reasonable? Yeah, does it make sense that we could, like, be a black hole backwards time and have things happen? No, it doesn't make sense. So for our answer, it would take 4 seconds after launching this particular ball for it to hit the ground. It'll take 4 seconds to go through its parabolic arc and then come on back down to the earth through the pull of gravity. Okay? All right, let's talk about number 40. So number 40 says, a rock 80 meters up the face of a cliff breaks loose. About how long does it take the rock to fall to the ground? So again, we're going to use that same formula that they told us to use. Plus C equals H. All right, so we need to get rid of 3 of the variables somehow. Okay, and here's the weird part. They gave me one number. How's one number going to get rid of 3? We're going to have to think about this one. So what does the 80 represent? Yeah, it's where it started initially. So that's your 80 meters. And you can tell it's going to be C because of the fact it has a distance label, and that's what C represents, is a distance. All right, so then how long does it just breaks loose. About how long does it take the rock to fall to the ground? Oh, ground, what does that tell us?
0.
For H. So, now, it didn't mention upward initial velocity. What's our V sub 0 in this problem?
0.
Yeah. Did you throw it? No, it just went, it just fell. So there's no velocity being given to it. The only thing that's attached to that rock, gravity pulling it down. So there's no initial velocity in this one.
Do you want us to memorize that?
No, because they're going to give you that formula because it's going to be different for each particular situation. I think it has to do with the object's initial velocity. So for smaller objects and smaller distances, that -5 is reasonable. But when you're talking about bigger objects, now you may be talking that -16. So they're going to give you that equation. They're not going to ask you to write this equation, okay? At least not yet. All right, so we got everything we need. We got -5t squared plus 0t plus 80 equals 0. Or in other words, -5t squared plus 80 equals 0. So what do you think we should do on this problem? We've got some options how to try to solve it. So, Justin, what do you think?
Subtract 80.
Okay. Because we don't have a linear term here, we can try isolating the squared term. So we subtract 80 from both sides, oops, and we get -5t squared equals -80. Okay, then what? Allison? Okay, well, because they're on opposite sides now, factoring out won't work so well, but I could divide both sides by -5. Because again, my goal is to get it just t squared because I want to take a square root, and I can't take the square root of a negative or of an odd number. That's just, or non-prime, or non-perfect square. So the two negatives cancel. 5 goes into 8 once with 3 left over and into 36 times. Oh, isn't that lovely? All right, so now we get to take the square root. But remember the issue we have with taking square roots is you have to write plus or minus on the other side when I take the square root of a variable. So I get time can either be 4 seconds or -4 seconds. So is there an answer that's not reasonable? Yeah, again, you can't do it in an absence of time. That doesn't make sense. So weirdly enough, the answer to this problem is the same as the answer to the other one. I'm going to tell you it's not always 4 seconds. And so we get, it would take 4 seconds for that rock to hit the ground. Okay? All right, then looking at number 60, this one has a if you look right above 59, it gives you a little piece of information. It says when an object is dropped or thrown downward with an initial downward velocity v sub 0, the approximate distance d in meters the object travels in t seconds is given by the formula d equals 5t squared plus v sub 0t. So now they're redefining variables for us in number 60. So what's happening is number 60 talks about, I'll go to a new page. Oops. One of the coolest things in the universe. A tall concrete chimney was imploded at a copper smelter in McGill, Nevada in 1993. A piece of the concrete from the top took 6.75 seconds to reach the ground. The question is, about how tall was the chimney? Imploding is usually something that's done to get rid of a building that is unsafe. They put in explosives, and literally, it's just like the whole thing just caves in on itself. It's just, it's freaky to watch it. And you should probably go on YouTube and look at imploding of buildings. It is like, that's not possible. It just looks strange, okay? Gotcha.
I saw a video of them do it, and when they do it, do they have like people around, or do they evacuate the area?
Oh, they have to evacuate the area, yes. Because here's the problem with this, is anytime you implode, if you look at the picture that's in your book, what do you see is happening? There's a lot of dust and stuff coming out, which is actually not really safe for humans to be around. So you don't want them to stand right next to the building going, wow, this is awesome. They're still probably going to get knocked back by that smoke cloud coming at them. So you want to have some safe distance. So because you're imploding, that means you're not throwing anything. So they're saying we're going to use this formula, d equals 5t squared plus v sub 0 t. And in this case, they say d is the distance the object travels. So I'll write that in here. So anytime you're given a problem like this, they're going to tell you what each of the variables represent. Other than, well, they will tell you t for time, but usually we know that one. Distance object travels. t is time. And v sub 0 in this particular case, notice that we have a positive coefficient in front of the squared term. That's because this is the whole work of gravity is not fighting against an upward velocity. It's all down, so it's a positive relationship. And then we have, this is the initial downward velocity. So in this problem, again, it says, when a tall concrete chimney was imploded at a copper smelter in McGill, Nevada in 1993, a piece of concrete from the top took 6.75 seconds to reach the ground. About how tall was the chimney? Okay, so in this problem, what does the 6.75 represent? T. Okay, now, was this dropped or thrown with an initial velocity? Okay, what was the initial velocity? It didn't have any. The building was imploded and it just fell. That's not being thrown or purposefully dropped, okay? So in this case, your v sub 0 is your 0. Because remember, we can only have one unknown, and what we want to know is d. We want to know how far did this piece have to travel. So we're solving for d, and we're going to get 5 times 6.75 squared plus 0 times 6.75. So our job is to figure out this guy. So we're going to have to do some math. So 675 times itself. We get 25, 35 and 2 is 37, 30 and 3 is 33, placeholder. 7 times 5 is 35, 49 and 3 is 52, 42 and 5 is 47, placeholder, placeholder. 6 times 5 is 30, 6 times 7 is 42 plus 3 is 45, 6 times 6 is 36 plus 4 is 40. So I get a 5, I get a 12, I get a 6, I get a 15, I get a 5, I get a 4, and there's 1, 2, 3, 4 digits after the decimal point. So then I get to take that answer, and by the way, if you're going to round an answer, it doesn't get rounded until you've done all the calculations. This happens all the time in the geometry class where kids round too soon, and then they end up getting an answer that's way too rounded. Okay, so now we're going to multiply by 5. We get 25, 10 and 2 is 12, 30 and 1 is 31, 25 and 3 is 28, 25 and 2 is 27, and then we've got 20 and 2, bless you, is 22, and again we had 1, 2, 3, 4 digits after the decimal point. So doing all the calculations, we get 227.8125. Now, the question said, about. So what do you think would be a reasonable estimate for the answer on this one? Tristan.
225.
What would you do? Why would you do that to the poor 7?
I thought it was like about.
Yeah, but you don't about the 7 down. Help him, somebody, Josh.
228.
Yeah, now here's a reason why that's as far as, yeah, you don't hurt him, you hurt everybody else. Remember we talked about significant digits? How many significant digits were there? 3. 6, 7, 5. So your answer should have 3 significant digits. This 8 is going to make this 7 go up. So I agree with the answer of 228. Now we got to get a label on it. What would that label be? You know that's, oh, yes it does. Yeah, distance in meters. Yeah, right in the directions. So, 228 meters. So, I'll add that to here. It did say distance the object traveled in meters. Okay? All right, so that leaves you with 3 problems on your own and the next 10 questions in the 2014 final. So go for it.